Alright, enough Tristram. Why is this not working? Error loading data, even better. Okay, that's fine. Hello. Oh, now you pop up. Thanks, Me6. Bit of a delay there. Okay, that's up. Yeah, so I don't have a chat in my stream manager for some reason. So I think what I'm gonna have to do is watch over here. This is gonna be fun. Okay. Or maybe watch over here. It's gonna be the best way to do this. All right, and does this work? You need a third monitor. Maybe you should plug one of these in. Okay, this works. All right. I guess we're gonna have to go this way. Sorry. Nothing like technical difficulties. So I guess you change your account name, and then that breaks everything else, even though all the settings are up to date. Okay. I guess we'll leave this right here. I'll try to keep an eye on that. So today, the plan is to actually follow the correct schedule. So today, Dalton's going to go over sprite animation. And Thursday, Olivia and Connor have their presentation, so we'll do that. And then the last day, the 14th, Yasmin will talk about Disney. I'll wrap up a little bit on ragdolls. And that will be, I think, pretty much it. If we look at the 16th, I think we have, yeah, 16th, so the last day we'll have some kind of open playtime for labs. So that is the plan for everything else. So with that, now that I think that at least everything's minimally working, still can't connect to the chat over here. We will do some 2D stuff today. So one thing to point out, I'm sure that the guys that are working on the Unity Binding of Isaac like have probably come across this. But one of the pretty interesting, yeah, I did notice that. We'll dampen the sound a little bit just in case. But if you are interested in doing a 2D game, there's this 2D roguelike tutorial up on the Unity tutorial site, and it's actually pretty cool. I haven't gone through it myself, but it's an interesting way to get kind of a pretty roguelike rather than, something that's a little bit less pretty, or not pretty, but a little more basic, I suppose. All right, it can take forever. I think I've shown this in class before, but this is a very simplistic, not simplistic, but the graphics are a bit simpler. So something kind of like this versus something that is a little bit prettier like this, basically. Yeah, it's definitely a good tutorial. Um, I just didn't have the patience to go through it all. Yeah, you got 25 minutes, 45, 35 minutes. So honestly, not that bad for kind of a fully polished game. Anyway, without further ado, we will hand it over to Dalton, and then he will hopefully answer any of your questions. So,
hello everyone and welcome to my Sprite animation presentation. Let's get right into it. What are sprites? In computer graphics, a sprite is a two-dimensional bitmap that is integrated into a larger scene, most often in a 2D video game. Originally, sprites referred to independent objects that are composited together by hardware with other elements such as a background. The composition occurs as each scanline is prepared for the video output device, such as CRT, without involvement of the main CPU and without the need for a full-screen frame buffer. Sprites can be positioned or altered by setting attributes used during the hardware composition process. Examples of systems with hardware sprites include the Texas Instruments TI-99 4A, the Atari or the Commodore 64, the Amiga, the Nintendo Entertainment System or NES, Sega Genesis, and many coin-operated arcade machines of the 1980s. Sprite hardware varies in how many sprites are supported, how many can be displayed on a single scanline, which is often a lower number, the dimensions and colors of each sprite, and special effects such as scaling or reporting pixel-precise overlap. Use of the term sprite has expanded to refer to any two-dimensional bitmap used as part of a graphics display, even if drawn into a frame buffer by either software or a GPU, instead of being composited on the fly at display time. The act of manually creating sprites, as opposed to pre-rendering them or using digitized images, is a form of pixel art. It is sometimes referred to as spriting, especially in the hobbyist community. Now, what is a sprite sheet? A sprite sheet is an image that consists of several images, which are sprites, and or animations. Combining the small images in one big images improves the game performance, reduces the memory usage, and speeds up the startup time of the game. Now, how do we make a sprite sheet? Well, let's say we have one single sprite that is represented by a width and height in pixels. Let's say our sprite is 140 by 140 pixels. For each pixel, some amount of memory is required to store its color, which is dependent on color depth, which is by default 32 bits or 4 bytes. So the complete memory usage of our sprite is 140 times 140 times 4, which is 76 kilobytes. Depending on your graphics hardware, you might only be able to use specific sizes for your sprites. For example, a power of 2 or even worse, squared sprites. For this, a sprite must be padded with additional unused pixels to match the hardware's constraints. To meet this requirement, our sprite must be expanded by 256 by 256 pixels. This increases the memory usage, now using 256 kilobytes, which is more than 3 times the original sprite size. It's not much for a single sprite, but now imagine creating multiple sprites, objects, characters, animations. You're going to easily end up with hundreds of sprites, each wasting precious resources. But what if we could use all that wasted memory after all? Now, imagine packing more sprites into that space. Here we have the sprite sheet. Now, only the complete sheet has to meet the hardware constraint. Therefore, our memory usage is much lower. But there's still more we can do. We can squeeze out the transparent parts of the sprite sheet, packing them even tighter together. There's even more we can do if memory is still scarce. For each RGB value and the transparency or alpha value, we have a representation of 8 bits, totaling 4 bytes for each pixel. We can reduce the color depth to 16-bit by squeezing out some of the colors. This results in a reduction of memory usage by up to 50%. So, how to animate with sprite sheet animation. When it comes time to add animation to your game, there are two primary ways to go about it. We're going to be using sprite sheet animation, which I just discussed. Another type of animation is called skeletal animation though, which binds bones to our sprites, and that allows us to only draw the character once, and then we can play around with it in a software like Unity. However, I'll leave the full explanation of this type of animation for someone with more knowledge. For this presentation, we're just going to be using a free 2D asset pack from Unity called Sunnyland. Provides us with all we need to begin animating for a 2D platforming type of game with a lot of the work already done for us. As well as this, I'm going to be taking some resources from another YouTube tutorial from the channel Brackies. So let's get into the actual animating video. Alright, let's get into the animation. So this is assuming that you already have a background and a scene all set up, colliders set up, rigid body for your player, and kind of a script for the 2D movement already set to your player. So all this is going to be is the animation side of things. I'm not going to get too nitty gritty into the scripting and movement. So what I have set up here is I already have all the movement, the rigid bodies, and the collisions all set up. So if I click play here, you're going to see that I am able to move around freely. I have jumping, and I can even crouch beneath this little object here. But obviously there is no animation, so let's get into the animation. So what you're going to do is you're going to want to open up the animation window by clicking Window, Animation, and Animation once again. So now that we're in here, we need to create a animation clip because we don't have one yet. So we're going to click Create. Make sure it's in the folder that you want it to be. Mine's just called Animation for ease, and we're going to start with the idle animation because that's what we want our default animation to be. So we will name this Player Idle. Go ahead and hit Save, and then we will go into our idle asset folder and take all the images we have here, go ahead and drag and drop into our animation window. Now if we hit play, you'll see him freaking out up there because it thinks we have 60 images in here and it's trying to render at 60 frames per second, but we only have 4, so it's just going to loop these 4 over and over again. So what you could go ahead and do is just hit this as 4, hit enter, and then hit play, and now we have our idle animation. Perfect. So what we're going to do now is go back and we're going to create our run animation as well. And we'll name this Player Run. So now we have our run animation. We need to go into the run folder, take all the images, drag them in once again, set our samples to 6 since we have 6 samples, and now we have our little run animation. Okay, perfect. Now let's see what happens if we click play. Let's see if this is all we need to do. Well, it looks like we got the idle animation in there, but if we move around, there's no run animation. So what we need to do is actually open up our animator window. So we're going to go to our animation folder where we save the animations and go ahead and double click on our player controller, and that will open up our animator window. So as you can see, by default is going to the player idle animation, which is good. That's what we want. But we want to transition to the run animation if we're moving. So how do we do that? You go ahead and right click on player idle, click make transition, and link it to the player run animation. Now, if we just leave it like this, it's just going to transition to run, and your character is going to look like he's running all the time. We don't want that. So what we need to do to have it transition is we need to make a parameter and a condition. So go ahead, come up here, and click Parameters, and make a new parameter of type float. And we will name this speed. Now, you can come back over to the transition, and where it says conditions, we'll add a new condition. If our speed is greater than whatever value you like, we'll just use 0.01 transition to run. Now, we want our transition to be instant since it's just 2D images. So we're actually going to click as exit time off and set our transition duration to 0 so we get that instant transition. Normally with most 2D games you're just going to leave this off as you want an instant transition to your image, unless you want a delay with 2D, or in 3D where you'll constantly be messing around with this as you need delay in actions. But for the sake of this video, we're just going to have everything with no transition. So if we stop running, we need to go back to idle. So we'll just make another transition, back to idle, come into here, and set the condition. If our speed is less than the value we set, which was 0.01, it'll go back to idle. Again, set the transition to 0, and now we should have a working idle and run animation. So let's go ahead and click play and find out what happens. And there we go. We have our run, and if we stop, we go back to idle. Perfect. That's exactly what we want. Alright, so now we can work on the jump animation. So we'll go back into our animation window, and we will create our player jump. And while we're at it, let's go ahead and create our crouch animation. Here we go. So we'll jump back to our jump, no pun intended, go into the jump asset folder, drag our jumping in, set these samples to 2 since there's just 2 images, and click play to double check, and it looks like we got our jumping and falling animation. Same thing for crouching. Head over to crouch, go into the crouch folder, grab the crouch images, drag and drop, samples set to 2, and let's make sure it's working. Perfect. We got the little crouch and the tail wiggle. Alright, so we're done with this window for the time being, so we can go ahead and close out of it and head back to our animator window over here. So now, as you can see, we have player jump and player crouch. So for the jump animation, it shouldn't matter what state we're in. We want to be able to jump no matter if you're crouched or running or idle. So we could take a transition from every single one into jump, but that would take forever. If you had tons of animations, you don't want to do that. So that's where this any state transition is going to come in. Because we're going to be able to use this any state straight to the jump, so if we're in any state, you'll still be able to jump. So let's go ahead and bring this down here, get our entry out of the way for now, bring our player jump over here, and we'll make a transition from any state to player jump. And so now, if we're jumping, we need to create another parameter to tell if we're jumping or not. So we'll go ahead and create a bool, because it just needs to be a true or false value, and we'll name it is jumping. It'll be false by default, but we will change the conditions based off what we want. So from any state, if we are going to the player jump, we want is jumping true, and then it'll play the jump animation. Again, we need to set the transition to 0 for the smooth transition, and then from jump we will need to make a transition from idle, or if we land and we are running. So for idle, we'll set the condition is jumping false, but we also need speed less than our value of 0.01. These conditions are great because you can add as many as you want depending on the type of animation or game you're making. Once again, set our exit time off, transition to 0, and then for our run we will actually set is jumping false and speed greater than 0.01 because we want to be running. Set this to 0 and exit time off. And now we should, after our jump animation, we should be able to go back to idle or run. So let's check it out. Alright, what happens if we jump? Look at that. We can go from jumping to running or idle. But I don't know if you guys have noticed, but we're not getting the falling animation. Why is that? Let's go check it out. So if you see here in our transition, if we go into settings, we have this box check, can transition to self. So what's actually happening is it just keeps transitioning to jump while we're in the air. So what we're going to do is just uncheck that box, go back to our game, and now we should get the falling animation. Look at that. Smooth as butter. So now all that's left for us to do is our crouching animation. So we can go into the animator, and if we are on the ground idling or running, we want to be able to crouch. So we'll go ahead, make a transition from running to crouching. Actually, I don't think we need that. We might just be able to do it from idle and back. Let's find out. Alright, so let's check the transition from idle to crouching. We're going to also, the same thing as jumping, we're going to need to be able to tell if our player is crouched. So we'll make another bool called is crouching. And false by default. We'll go into our conditions here, and if is crouching is true, our player will be crouching. Set these to 0. Head over to our other one, set it to 0 while we're at it, and we will set the condition is crouching false. So now if it's false, we'll go back to idling. Alright, let's find out what happens. So we got our crouch and not crouch. But if we try to crouch while we're running, nothing will happen. So what we're going to need to do is actually link it up to the running as well. So same exact thing, make transition to crouch, make transition back to run. And we'll set this to 0. And we'll do the speed shouldn't matter, just is crouching true, and then if is crouching is true, go to crouching. Oh no, this should be false because we're going back to run. Set these to 0. I believe I did that for this one. Yes. Okay, so we should get this crouching animation now. Perfect. There we go. Look at that. So now we can crouch under here. We can move around. We can even jump while we're crouched too, so that's good. So it looks like everything's smoothed out now, so perfect. So that's really all you need to do. So this was all previously done when I loaded up this project, but if you wouldn't have had all this previously done, you would have had to actually manually work with this player movement script here to set certain values, such as we have in here, our speed is jumping and is crouching, we actually have in our script, as you can see right here. So we have our public animator variable that we are using to change the speed, as well as checking if we are jumping, which is our is jumping in Unity, and if it is true, then our character will be jumping. As you can see, if we press up on our keyboard, we'll be jumping, so that'll set to true. And it's the same thing with the crouching. If down, we will be crouching. And then we also have on our on landing, when we collide with the ground, we will set as jumping to false, so we'll no longer be jumping. So that's where these variables here come into play with our program, is that way. So with all of that in mind, that about wraps up the 2D animation in Unity, at least. I'd like to thank the creator of the Sunnylands asset packs, as well as the YouTube channel Brackies, for most of the content and the scripts and knowledge on how to do 2D animation. Like I said, if you would like to set this up yourself, there is tutorials out there on how to get it all set up with different assets or the same assets as I used, and there are many different tutorials on how to further your sprite animation. But for the simplicity, I just wanted to show you how easy it is to get a 2D animation set up with sprite sheets in Unity. And as you can tell, it took me about 10 minutes to get everything set up, moving around, and animated. So with that, that will be it for the animation part in Unity. So here's another type of animation with sprite mapping as well. This is a like isometric type view type game that I've been working on for a while, and the images are actually loaded in order because that's how the code reads them. And as you can see over in this window, I have in the top left that these are all the individual images depending on where your character is looking, walking, and what action he's performing. So for each piece of clothing in the game, there's actually 17 just static bitmap files that are for each different direction in which your character is moving. As you can see, this one, he's facing this direction in the game. I think in this one, it looks like we're doing the attack animation, in which case this is what the clothing will render. As well as the armor is also how the weapon, the spells, everything is rendered in the same way, just in static bitmap images. As you can see, this NPC in this bottom left window I have is walking around based off just static images being loaded in a certain order and called upon when the character is walking around, as that's the walking animation that's just being loaded, and then he goes back to his idle standing in whatever direction he's facing afterwards. This is the typical kind of animation in all like these types of old school pixel art games, is all just going to be static images in the forms of sprite sheets, as we discussed before, or loaded in just single image files one by one in a certain order given a code, such as this game uses with its code and bitmap files. So this whole game is just all these objects, your character, all the weapons, item, monsters, and health. It's all just static images that are updated when different stuff happens. And even though we have this isometric, like top-down, like 2.5D kind of view, everything is just drawn in 2D and actually doesn't have any third dimension type to it. It's all just drawn in. You can even see over here this table is kind of clipping over these stools because it's not drawn to handle objects in a 3D way. They're just drawn on, and depending on what's on the map at the time, it's just going to display the default image that's loaded in. So you'll sometimes experience clipping right here. As you can see, this table that looks like it's sitting on the stool and giving a kind of master impossible illusion of how that's actually happening. But that is how this game is done in a lot of old school like RPGs like this, and MMORPGs and the sort are animated with just static files like this. So, how do sprite sheets relate to OpenGL? Well, how the performance of OpenGL is actually increased is by the use of sprite sheets. So what would happen if you use individual sprites instead of a sprite sheet for your game? Well, first of all, the game would need to tell OpenGL which sprite to paint. Next, it needs to tell OpenGL which part of the sprite to draw. And finally, it needs to tell OpenGL where on the frame it needs to draw the sprite. With this information, OpenGL can begin drawing the scene. But while OpenGL is busy, the game has to wait until the next commands can be processed. This procedure is now repeated until all of the sprites are drawn, and the faster that this happens, the higher the game's frame rate is in the end. Obviously, there is a lot of communication overhead going on between the game and OpenGL, which is obviously not an ideal solution. A better solution is to use a sprite sheet like we discussed previously. For this, we're going to need an additional module in the game called a sprite batch or a sprite atlas. What this module does is it collects all of the data required to draw the sprites. A reference to the sprite sheet, a list of source coordinates which contain the parts of the sheet to be copied from, and a list of destination coordinates where the sprites have to be placed on the screen. Now, the communication between the game and OpenGL is actually quite simple. So we set the sprite sheet, set the source coordinate list, set the destination coordinate list, and that's it. OpenGL can now draw the scene without interruption, and now the game can handle other things on its own, like handling player input, or calculating collisions or object movement. So, as you can see, using sprite sheets is a great use as they reduce memory consumption, speed up the drawing process, and keep the frame rate high. So, in conclusion, hopefully you understand more about sprite animation and how sprite mapping is the most efficient way to do sprite animation. Now, with this knowledge, you should be able to understand how games like Earthbound and the Legend of Zelda, old Legend of Zelda games were made, old school RPGs like the one I showed you guys in the isometric view is made. They all use variations of sprites and sprite mapping to save memory consumption and make the game overall have better frame rates and be able to handle all of the rendering and drawing that is going on the monitors as the game is running and displaying all of these images at the different frame rates. So hopefully you guys understand sprite animation a bit better, and I hope you guys enjoyed my presentation.
There we go. So that's pretty cool. Does anybody have any questions for Dalton at all? Yes. Clap, clap, clap. Very nice. I've got my chat on my phone here, so I'm not ignoring you all, but kind of trying to keep an eye on. Oh, you guys don't get to learn about containers. That's the other group today. All right, yeah. You guys are so nice and formal with each other. I'm sure that's intentional. Yeah, it was really interesting. Um, Do you want to talk a little bit about the game that you've been working on, the isometric one? Because that actually looked pretty interesting to me. Um, Said that you've been working on it for a little while. I'm kind of curious, is it like a standard role-playing game? Is it a MMO type thing? Kind of looked like you had I don't know if any of you are familiar with Ragnarok, but it looked like you had players just kind of sitting, idling in like a store type of a setup there. I guess I just want more detail. It looked really neat. It's an MMO. Okay. Oh, gotcha. Um, that's pretty interesting. What's the underlying engine? Oh, that's cool. Your own private server. It kind of reminds me, there was when I was in undergrad, there was like a glut of kind of not tech demos, but people were trying to come up with the next MMO. Um, World of Warcraft hadn't really started yet. It was basically like Ultima Online or Ragnarok if you're into the Korean ones. There was Dark Age of Camelot, and people were trying to just come up with like the next big thing. So my roommates and I would oh, Endless Online, okay. I think I've heard of that. But anyway, there used to be I think it was this MMORPG.com. There was like a list where you could filter by betas, and it's probably still here. It's just a little bit prettier. But like you could find any MMO that is going through a beta test so that you could sign up for free and play for a while. It was kind of fun to waste time. There was an old one I remember where we just spent so much time cooking spider legs and leveling up our, our cooking abilities. But yeah, that's really neat. That's it's kind of cool that you've been playing around with that. I've always wanted to set up a yep, awesome. I've always wanted to set up a shard of like Ragnarok or Ultima Online or an old game, and then I realized I just don't have the time to sit in and manage it. I had a Minecraft server going for a little while, and I got as far as setting up a spawn world, creating doors to creative and survival, and I think I had like a roguelike mod, and then school started, and I had to spend all my time prepping for class instead of I'm a 99 cooking Chad. Exactly. MMOs are fun. Enjoy them while you have the time, because that time very quickly dissipates. So, um, good stuff. So yeah, then Thursday we'll have two more presentations. So I'll just wait to hear from Olivia and Connor for that. Yeah, Ragnarok servers are a pain. I agree. I wanted to do a RuneScape one, but apparently that's even worse. And I had one of my former students tell me that he was into setting it up, and apparently people would bully other server owners if you're getting user. It seems like there's a very um, weird thing behind there. Um, so we can get going with the rest of the 2D stuff. So basically, Dalton talked about the sprite animation, which is a key characteristic of a 2D game. Like you said, it's great for memory. It's great for um, yeah, basically just making your life a lot easier. And I will say, it is so much easier now to handle sprites and animations and all that. That kind of node-based flowchart view of transitioning from one state to another. Um, just simplifies things. And I'm very glad that you went in and talked about the code too, because I was going to ask, do you even have to touch code to transition from one state to another just based on what you were showing? So it's good that you had the controller. We're going to talk about kind of the basics that he didn't rig over. So things like the rigid bodies and the colliders and all that fun stuff today. But if you are going to go ahead and do something like that by hand, say you go into the OpenGL like he started talking about, or even um, in something like Phaser or Babel, or not Babylon, but Pixie.js or any of those kind of 2D game engines, you might need to manually script that out. So how long is each animation frame going to last? What are the pixel perfect offsets into the sprite sheet? Um, Create your own transitions inside the code rather than having a nice little Unity-based kind of drag and drop type of thing. So again, I think I'm going to start sounding like a broken record, but Unity makes things so much easier for this kind of development. Um, so let's see. Yeah, we're going to talk about 2D. I'm going to go through about maybe a third of a tutorial with you guys. So I've got this game development.blog link here at the bottom. This is basically what we're doing. It's kind of a 2D space, um, like a shooter kind of a game where basically you are a circular object, the enemies are circular objects. You can shoot at each other, you can change up your weapon type and all that kind of standard stuff that you would have in a space game. But it's a great example of how we can use the tools that we know in Unity, except applied to the 2D space here. So here we have a 2D game, and I'm gonna kind of gloss over some of this because again, Dalton already covered a lot of it. But our viewpoint is basically this 2D perspective, so we don't really have a Z plane anymore. One of my children is screaming downstairs. I'm sure it's fine. Um, Anyway, so everything we've done so far is 3D, right? So every time we've picked a new Unity project, we've been picking this 3D thing, ignoring the rest of them. So today we're going to talk about 2D. We're also going to look at some of these other options too, because I think it's going to be useful for you all. Let me full screen this. Going to have to minimize it a little bit later because I'm going to copy and paste a bunch of code. But some of these other aspects too that you might be interested in. So 2D, obviously, this is a 2D scene. 3D is a 3D scene. What this is actually doing is it's instantiating Unity for the common workflows that you would need. So 2D, you're going to have access to like the Sprite engine. Your camera is going to be set to more of an XY plane. Might be like an orthographic camera type of thing. 3D, again, we've seen this so far, but it's more focused on the rendering pipeline, right? So we talked about the pipeline a long time ago. It feels like a long time ago. But that's basically what 3D is setting up for you on the back end. 3D with extras, this is giving you access to a newer aspect of the pipeline. So it's a post-processing stack. I honestly don't know too much about the details of the benefits of that. I just know that you have access to extra, basically post-processing tasks, not to just say the slide here, but you get extra features basically for your 3D engines. Then high definition. So this is basically giving you access to a newer shader model. So DirectX 11 and up, basically 3D by itself is just kind of the standard programming libraries. Basically, it's intended for more higher def applications. And then the last one here, which we haven't really talked about at all, is this universal project template. This is useful if you're exporting into many different environments. So this almost might have been better for my little ball roller, honestly, because we're putting it to WebGL, sending it to Android, possibly sending it to Windows or Linux. So it's intended for extensibility, perhaps performance or optimization. So this might be a better one to check out for that. But nothing stopping you from instantiating with 2D or 3D. Again, you're just getting access to kind of a default environment. You can always add on the stuff if you start in one project and you move to another. So 2D games, definitely a great aspect of Unity too. I don't know if any of you have seen Wizard of Legend. There is a YouTube channel that kind of breaks down the development of this game, not the developers themselves.
Okay, so hello and welcome back to
I'm not
another
gonna play this whole
video on my
thing,
channel, but in this one it's
but
going to be...
okay, super slow when I'm streaming here. If you haven't seen this, I mean, I'm sure you've all seen Binding of Isaac. This kind of a 2D game, but this was made in Unity. Now you can check the IndieDB page, and I think it lists out that this is a Unity game. But here you see all these lovely, very pretty animation styles. I haven't actually played this one. I've heard it's a lot of fun. I keep seeing it go up for sale in the various like Steam sales and all that, and I've never pulled the trigger, but it's kind of a neat game. Again, it's yeah, so definitely it's very polished, it looks like. So that's kind of the thing here with this game development is that it's a lot of fun to throw together a little tech demo. The hard part is optimizing it and polishing it and adding content, right? Because this kind of a game engine, it's probably pretty easy to program, right? You have like a dash, you have a bunch of abilities. The key thing is going to be how like perfectly flowing these animations are. Just the little touches which make it enjoyable, right? So yeah, again, there's that channel. It kind of breaks down the various aspects, and I think the person who is reviewing it said he was going to try to implement parts of it, not the whole thing. But kind of interesting if you want to check that out. And when Kyle talked about the procedural generation aspect, that would link in here as well, where if you have something like Binding of Isaac, I can't speak to Wizard of Legend, but basically your environment is going to be randomly generated as well, or procedurally generated, right? So you have all of the animations, you have the 2D collisions and physics engines and everything that's baked in there. And then you layer on top of that, drawing a dungeon from a procedurally generated perspective. Do you grab a predefined room and plop it down where that room contains, bricks of a particular aspect of your tile map? Is there like a candelabra or a torch where it's animated? That animation is like 3 or 4 frames in that sprite sheet. So it all kind of fits together here, which I think is a very interesting aspect. And those of you, that are maybe irked or not irked that I always motivate this in terms of games, um, I would argue that they're a lot harder to program than a normal forms-based application, right? Because there's just so much going on here. Not just in terms of the gameplay, but the things on the back end and the software engineering aspect of that as well. So to kind of bring it back here, 2D versus 3D. So we're going to have sprites instead of models. We'll have tile maps instead of terrains. Basically, we're going for, again, this 2D perspective. Now you can have models. I have seen games where the player character, the environment is all 3D models. Think of like the original Donkey Kong Country game for the Super Nintendo, where it's this beautifully animated 3D looking-ish game. But what they did is they took a 3D render and they mapped it to a 2D bitmap, basically. So they kind of cheated in a way. So pre-rendered graphics for that. So again, we're going to kind of walk through this in a few different slices. I'm not going to follow it perfectly. I'm going to kind of jump around a little bit. This is, I want to say it's like a 12 or 13 page series of tutorial posts. I really like this one because it is written. It is not a YouTube video. For me, when I'm trying to learn, okay, yeah, it's a 12-part series. When I'm trying to learn this stuff, I have a lot harder time following videos than I would do looking at like a blog of written out things with screenshots. So if any of you are going to go into making tutorial videos, do a blog post. It's a lot easier. So yeah, we're going to do parts of this. If you want to follow this through, it's not a requirement. It's more of a get you started with 2D or get you more experience with 2D. I'll leave the rest of it as an exercise to the student. Professor joke. If it's an exercise for the student, it means I didn't want to do the whole thing. All right, so I have a 2D game all set up here and ready to go. So let's pop over here. We'll ignore that. Love that I get this error every time I start up Unity. So this is a 2D blank project. So I clicked the 2D button and I created this project. What we're going to be getting to is just kind of two balls moving around, shooting at each other later on. So we have our camera. I'm zooming in, zooming out. Again, we just have a 2D space. There's no 3D gizmo up here. Basically, we just have your kind of standard 2D aspect. Still have your game location. The game background is blue by default. Make sure you change that later on. Still have our asset store. You still have 2D assets that you can download and play with. But, fairly straightforward. We have our main camera. Get our little preview here, and yeah, pretty much it. Life is good. So what we're going to do, this is kind of the precursor to Dalton's presentation if you're looking to figure out where this fits in with today. So we're going to create a player first. So how we're going to do this is that we are going to create an empty game object. And in that object, we're going to have it contain all the aspects of this player. Now, you could do this in multiple ways. This is the way that the tutorial is doing it. I'm going to follow along with that just for, clarity's or continuity's sake. I could have my sprite just by itself in the hierarchy if I wanted, but this is a little bit easier to control things. So we're going to create an empty game object. We're going to add a 2D sprite. We're going to pick an asset to render out. Later on, I'm not going to do that, but you would apply a sprite, like an image to that. You could apply those animations to the player object and all of that later on. We're just going to leave it as a knob, basically. And then we'll add a controller to this as well. So let me go ahead and get some stuff over here so I can see what I'm doing. All right, so we're going to create an empty game object. We'll call this the player object. All right, now inside of this, we're going to create a sprite. And you kind of see some of the other options here, tile map, isometric tile map. So you have options as always. So this should have been inside there. And we'll call this player sprite. Right, and naming these somewhat intelligently, I could call these all temp, or I could call this object1, object2. If you want to do like a game object.find later on, it's a little bit easier to name it something intelligently. All right, so we have our player sprite. We are going to get our project set up down here. Again, this is a blank project. I haven't done anything other than that. So let's create our folder for scripts. We're going to have a prefabs folder we're going to need later on. Prefabs, I'm going to put the bullets in there. I think that's good. Let's create a script. Let's call this player controller. My naming scheme's a little bit different than the blog post if you are following along. Let's get Visual Studio Code up and running while this is going. And then we are going to add something to look at for the player object here. All right, this is going to take over for a sec. All right, so I'm going to double click the player object, and you actually see it kind of, if you double clicked on an object in 3D, it would go to the frame of that. It would zoom in. You get a nice picture of the model. Here, when you double click, it zooms way out. It still kind of centers this object, but our object is to be quite honest, quite tiny right now. And it doesn't really exist. We haven't put anything on it. So we want to add a asset for the sprite. So here we're going to click. I have since learned they call this the nipple. I didn't realize that, but it makes sense. So we're going to put a knob asset here on the sprite. So now we see we have a little circle. To make it a different color, maybe like a teal, so that we can see it. We're going to put a little space background in as well. So yeah, we have our object. I could scale it if I wanted. We'll talk about layers a little bit later. I can stretch this guy out. So we're going to leave it as 1 right now. But if I hit play, it's going to be fairly zoomed out. We have a tiny little dot, and that's our player. Right? So nothing too crazy so far. Make sure we save our scene. So we have our player. Player's a knob. If you're British, that will be hilarious. And there we go. So here we have our player controller. And what's next? And we have some code. So I'm going to kind of dip back and forth so you guys get to see the rest of my desktop because I'm not going to type all of this in. Just going to copy and paste it for laziness. But what we're going to do on this player object, we're going to create a move speed variable. So how quickly does the player move? And then we will add some hit points, which we're not going to use for the purposes of this demo. But basically, every time I would get hit, this would decrement, right? So take off X hit points for whichever bullet hit me. If I have like a game manager spawning waves of enemies or spawning objects with different attributes, this is the boss, this is the mid-boss, this is a minion, they would all hurt me differently, right? So subtract based on which type of object has hit you. And then in the update function, we're just going to use a straight up update. And this is a kind of a temporary movement. So we're still going to get the horizontal and vertical axes. So this is the same as the ball roller where we're getting the arrow keys. But we're just going to basically translate the object. So this is all basically pretty similar to 3D space. So get an arrow key hit, pull the horizontal and vertical movement into a float. So basically what is the speed or which key is being hit, which direction, multiply it by the move speed, which again, this is our public variable, multiply it by our smoother, so this delta time, and then this is what our offset's going to be. Now, in 2D, we still have to deal with 3D vector movement. That's just the transform object is still in 3D. So basically, we're going to create a vec3 movement direction. So what's the horizontal offset? What's the vertical offset? So again, X and Y, horizontal and vertical. Now it's not X and Z. Z we're going to leave as blank, so 0. And then we're going to translate the player. Okay. So if you have any questions, please feel free to stop me. So we want move speed and hit points. So public float move speed, I'm just going to leave it as the lowercase. 5.0f, public float hit points equals 100.0f. Tacking on the 0.0f just for unit test, well, not unit testing, static analysis sake. Start we're going to leave as blank, and then update we have our update code. So let's paste this in. And is there a nice formatting in here? No, in Visual Studio you can automatically format it. I'm sure it's in there. Let's go ahead and do this. Yep. Good enough. All right, so here's the update code as promised. Go ahead and save this. Everything should be good. Oh, move speed is lowercase, so this will not compile otherwise. Horizontal and vertical movement are fine. Start, we're leaving as blank. Just initializing in our public space here. And then we have to apply this to our player object. So I'm applying it to the object, not the sprite. I am applying it to the object. There we go. So you see our public variables there in our inspector. And what we should have, assuming it doesn't break, okay, just have a ball moving around. Again, I'm just using the arrow keys here. What you would probably do later on is have a preferences, like a config file where if I want to use WASD or the Vim keys or the arrow keys to move around, you would pick that. All right, so kind of janky movement mainly from the streaming that I'm doing right now. It's a lot smoother if I turn off Streamlabs personally. It's when I went through the demo, it wasn't too bad. Alrighty, so we have our movement for our player. All right, this is going to be an object that collides with other things. So we want to make this a rigid body. Now you did this for the ball roller and your terrain environment where there's a rigid object on the player. So here we still want physics to apply. We want Unity to take care of that for us. So we're going to add a rigid body 2D component. And the options are a little bit different than the rigid body 3D component. You don't just turn gravity off, you would set the gravity scale. So I'll set this to 0. And then we're also going to set this interpolate option to interpolate. There's also extrapolate, but basically interpolate is going to minimize some kind of jankiness of moving the player around. It's still going to look janky for the stream, just again, because my computer is not great for this. And then we're also going to pull it in our script, and it looks very similar to the 3D. So it's going to be GameObject.getComponent rigidBody2D instead of just rigidbody. And we're also going to be smart. We didn't do this before, but we're going to add a little bit of error checking just to make sure that we have the object. Unity is going to complain regardless, but here we can make this a little bit more intelligent. So I have my player object. Again, I'm not the sprite, the object itself. We're going to add a rigidBody2D. So here's our parameters here. This is the gravity scale that I was talking about. We're going to scale it to 0. And then our interpolate, we're going to set to interpolate. I'm going to save it and then run it. And then, again, it's a little bit janky. You don't really see much of a difference, but it will help in the long run. And now we're going to get our reference here. So we want a private rigid body 2D RB equals I'm going to go back to, no, we don't want to do this. I'm just going to copy this. So we want a private for that, and then in start we'll pull it in. Okay. So we get a reference to the private object here. Save, compile. Good. Should be able to play with no issues. Yeah. Again, you don't see a difference because it's just a physics entity we're applying here. And then if we didn't have this component set, we'd get a log error that's going to be generated as well. So it is now a rigid object. And what we can do is we can change the update code a bit. So I'm going to copy and paste this again. Instead of update and then updating the position, we will basically do the same thing we did with the ball roller. We're going to apply a force to this ball so that you kind of get that nice, smooth, physics-based motion. So again, here, this is basically the same thing as the 3D ball roller. Get which arrow key you're pressing. We're going to apply, you'll create a float, apply the move speed to these axes. We're taking off the delta time because it's going to be super slow otherwise. And then the other difference here is that we're going to create a vec2 instead of a vec3 because we're going to add a force, not a transform. Trying to figure out if that's a deer or a giant dog in my backyard. Looks like a dog. I swear I don't have focus problems. So yeah, basically we're going to add a 2D force instead of a 3D force here. And this is not vector, it's vector. All right, so what we're going to do is we're going to go back here. We're going to comment everything we did and update out because we don't need it anymore. Could also just delete this, but we'll comment it. So now again, we have this fixed update instead of update. And if you don't remember why we use fixed update, we use it to basically handle physics-based actions. So fixed update. And then this, again, I need to fix this because this is move speed, not move speed. All right, so we're basically applying an action to the rigid body, not just the transform of the object. So we hit play. Should work fine. So basically I'm getting a momentum. So I'm taking my hands off and it's still moving, kind of a thing. So we have that. Basically, again, the same or very similar code to the ball roller code. Okay. I'm assuming everybody's good so far. So now we're going to add a background, and this is where we start talking about things that are a little bit different than what we've done before. I have this already, so this is basically a nice tileable background image. I have it in my other demo project that I was working on to make sure that this demo would work. So it is in Assets and Space BG. And I'm going to put it in my Assets directory. So this is one other thing you can do. Again, if you're not familiar with Unity, those of you that are well familiar, don't worry about this. But if you're going to download an asset off the internet, like a tile map or a background or some kind of an image, and you want it accessible to Unity, you can either drag and drop it in straight into the editor, or you can just put it in the assets folder and it will pop up. So now what I'm going to see, if I click assets, here's my space background. And then I have all of the aspects of this thing that I want. It's basically automatically imports it. But we have many, many options that we can play with for that. So we have our background. So we want to change it. So we want the mesh type to be a full rectangle. We want to, this is a attribute that we want to set for the background here. We're going to create an object to hold it, and then we're going to basically add a sprite to that background object. Again, the same thing we did for the player, except instead of making it a knob, we're going to make it an image. All right, so mesh type is, where'd it go? So here's this. Mesh type, here it is. Instead of tight, we want a full rect, just to set that nicely. Apply. I forget, oh yeah, that's the other thing too. You have to hit apply. So if I make any changes in here in these import settings, there's a little apply button. So like if I change this to mirror, this apply would be active. We're going to ignore that for now. But make sure you click apply, otherwise your settings won't apply. All right, so we need a new background object. So we have a new empty game object. Background object. Background object needs a sprite, so 2D sprite. Call this background sprite. Save our scene. And then what we have to do is add an image here. Okay, so we are going to add an image. And where did my guy go? Actually, let's just apply it there. A little bit better way of handling it. All right, so we have a sprite. Okay, again, nice tiled background image. Well, it's not really tiled, it's kind of big enough, but we also want to set it to tiled, though. The width and height will be 100 and 100. So it is going to be tiled. And where is my... tiled 100 by 100. Okay. Save. So there we go. So now when I zoom out, we see all of these kind of 100 by 100 tiles. All right, so there's a background object. Now, one of the things which is interesting for Unity, and also consider this for any other kind of game that you create, generally 2D more so, but you can create layers. So if you are coming from a web background, think of this like your Z index, where if I want to have something on top of something else, consider again the camera's looking kind of straight down or straight at something. Which layer do you want to render first, and then second, and then third? So basically what's visible and what's not visible. Here, we can add layers to basically make sure that the background's like not on top of the enemies or the bullets, make sure that we can see everything we want. So here what we're going to do is we're going to create some layers. So we'll create a background layer, we'll have a default layer, an entities layer, we'll put like our players and enemies and bullets on that layer. And then we'll have a foreground layer for things that we want to put more so in front. So this is on our sprite. We want a layer. So sprite render, additional settings, sorting layer. So we want to add a sorting layer. So again, we want, background entities and foreground. So background, And then we want entities. And we want foreground. And we want background behind the default layer. And this is just drag and drop here. So background, default, entities, foreground. We have that right here. Kind of like adding a tag. So now we can go back to our object here. And we want to set this to be in the background. So now this object, the sprite, is in the background. Right? We want to put the player on the entities layer. So now if we zoom in, actually what we could do just to kind of demo this, let's put the background as a foreground layer. And let's put the player sprite in background. Player disappears. Right, camera's kind of hiding it, but now we can't see it because it's behind the background. So we want this guy in the entities. We want the background sprite to be in the background. You can use this to play around with various visual cues and fun things too if you want. Okay, so good so far? Right, so what we're going to do next is we are going to add a camera follow for the camera. So basically, again, similar to the ball, the 3D ball, we want the camera to follow our player along as I go through this massive 2D space. So what we're going to have is we're going to create a new script for our camera. So we're going to have a reference to our player. We're going to have a lerp speed. So basically our the speed at which we're going to smooth camera motion. And then basically, again, it's very, very similar. We're going to get an offset from our current position to where the camera is, and we're going to apply an update to the camera's position based on where our player is. So calculate the player position, calculate an offset to the camera, and then apply it very smoothly as we go. I'm just going to copy and paste this whole thing and just dump it into the script so I don't type all this out. But what we see here in the late update, and again, late update happens after all other game objects have updated. Basically, we're going to apply this vec3 lerp function. And again, this is like a smooth update to the transform here. So, scripts, new script, camera, controller. All right, and I'm just going to go ahead and delete everything. Insert this. I call this camera controller for some reason. So again, this is just copy and pasted from the slides, which was basically copy and pasted from the blog. Pure camera motion, what we have here. Now we're going to set this to our camera. And I have an error here. What's the error? Oh, silly me, I forgot that I don't delete the using directives. Otherwise, I don't have access to the Unity directives. Mono behavior does not exist. Okay, so we have our script that's been attached to the camera. Our camera script needs a reference to the player, which we'll stick in here by dragging and dropping. My lerp speed is changeable again, so it's a public variable. But now as I move, we can see my player move along with it. And again, it's janky because of the stream, not because of the script. It's very, very smooth if you don't use Streamlabs as it's going. We could change the slurp speed to see what happens. Let's change it to 5.0. It was 0.5. So it's a little bit not necessarily smoother, but it felt a little bit like it was very eager to follow my player along, basically. Let's put it that way. All right, so we have a camera controller, which is good. We're going to adjust the rigid body very slightly as well to make things a little bit smoother here. So I'm going to pop this over here just to make sure that I've got the right ones. Okay, so player object rigid body 2D. This is to basically get the feel of the player motion a little bit better, like an outer spacey kind of feel. So we're going to change the mass to 0.25 from 1, so it's going to be a less weighty. Linear drag is going to be 5. Angular drag stays at 0.05. Discrete, straight awake. And then player move speed, we're going to bump up to 10. So again, this is in the slides, and this is going to get us just a little bit of a different feel of our player. So it's more like I'm not pushing a super heavy ball through mud. I'm pushing, an object in outer space. It's got a little bit smoother motion, lighter motion, I suppose. All right, so back over here, we have a minor rigid body. Okay, so we have camera, we have a ball. Effectively, it's a direct transition from 3D to the 2D ball roller. Nothing horribly different here. Where things are going to diverge a little bit, I don't know if we're going to get through all this in time, so I might leave some of this as an exercise to you guys. We're going to add bullets, and let's I'm going to skip through the bullets just because I want to show the enemy at least before we're done here, because I think that at least the enemy is a little bit more interesting. I'll talk through the bullets here really quickly. So basically, we're going to create an empty object. We're going to create a sprite for the bullets. We're going to make it a prefab, and then we're going to delete it out of the hierarchy. And basically, our script is going to handle instantiating these bullets and basically keeping them alive for a certain amount of time. So the update here is basically it's got a life timer. So for a certain amount of time, this bullet is alive. Once the timer goes away, it dies, it gets destroyed. One thing that I will mention is that this can have a detrimental impact on your performance if you have a ton of objects being procedurally drawn like this. Generally, what you would do is have a pool of pre-created game objects, say like 100 bullets, and just they would be not rendered, they'd be off screen. You would then make them active when their life timer is active. You'd set their transform to where they need to be. Instantiating and destroying things a lot of times will actually be worse from a memory perspective. For this simple 2D game, it's not a big deal. You won't really notice performance decrease. But if you're starting to make like a shmup type of thing where there's millions of bullets on the screen, you might see definitely something a little bit slower. But we're going to skip through the bullets unless we get back, get some time. What I thought would be kind of more interesting is a AI, so basically a very simple follower. So we're going to create an enemy, and you can make this a prefab and have a game manager, spawn these as you go. But we haven't really talked about other objects with some intelligence to them here. So to make a very simple enemy AI, you're going to need a couple of things. So we would need an object to hold it. If it's 2D, it's a sprite. If it's 3D, it's a model, with animations and all of that. It's probably going to have a rigid body and some colliders on there. We're actually going to have 2 colliders for our enemy AI. And then we'll have some scripts to handle the movements, maybe decision making if it's a smart enemy. So basically all the attributes that you're going to need here. And again, this is where we start diverging a little bit from the step-by-step tutorial. So we're going to create an enemy object. We're going to do basically the exact same thing that we've done before, except it gets 2 circle collider 2D components. So one of them will represent the actual object. So this is going to be very tightly bound to the player, or sorry, the enemy character. And then the other circle collider will be a lot bigger. So basically think of it as its sensing radius. Okay, so if anybody breaks the boundary of this huge circle, a function will be triggered. It's up to you what happens in that function, but this is basically our collision. You can make a very simple stealth-based game in this where you have your guard, there's a radius or a cone or something like that, and if the player gets inside that little cone of light, trigger a reaction kind of a thing. So this would be one way to do that. So let's go ahead and create our empty enemy object. So let's call this enemy object. Enemy object gets a sprite. Sprite. And enemy sprite. Okay, enemy sprite is a knob. Okay. Enemy color, let's make him some kind of an angry blood red. And we're going to scale him out by, let's say, 10 by 10. So we kind of have a big, angry guy. And let's position him over here. I'm just picking random values at this point. I'm not strictly following the tutorial for this. All right, so our object needs a rigid body 2D. Again, so rigid body 2D. We want its gravity again to be 0. We want it interpolated. And I think that was it for rigid. And then we need our 2 circle colliders here. So I'm going to minimize that because I'm done with transforming rigid body. Circle collider and another circle collider. I could have just hit enter. All right, so now we see, oops, I screwed up a little bit. One moment. Let's reset the transform. Reset. Okay, Sprite. Oh, that's what, okay, I did that wrong. Yeah, I screwed this guy up quite a bit. So what I did is I was scaling the sprite, not the actual object, which made the sprite bigger, but the actual object was tiny in a different location. So we want this guy in the foreground. So I went through, I reset everything basically. So position, scale, these are all resets. I want to apply my position change over here to the actual object, not the sprite. I knew I was going to do that at some point. I'm surprised it hadn't happened already, to be honest. All right, so I moved it over. I scaled it, and now we're going to play with our circle colliders. So the first one, where's my collider here? This should be like 0.1, I think. Yeah, so this little green ring is the collider. So anything that interacts with this boundary will collide. I think this is actually supposed to be 0.9. And then we should have a nice, where's my, oh, 0.09, sorry. 0.09. All right, so maybe we'll make it a little bit smaller, 0.08. So again, you can, 0.085. All right, good enough. So you can see how you can basically bind these colliders. We were doing the same thing in 3D space with like the capsule colliders before. And then this other one, this bigger one, this will make our sensing radius. So right now it's at 0.05, so we could basically make this object as, large as we want it. So let's say 0.5, so we'll make it a nice big one. So one's going to represent the physical object, one will represent a trigger. I have the settings that I used in here. Again, I was dinking around. So basically, the view radius we want to be a trigger, the other one we do not. So is trigger for the bigger radius. I'm not triggering the other one. If I didn't click this, actually, let's see what happens. This is kind of fun. I think I'm going to get kicked out. Maybe, oh, you know what? I have a rigid body, right? Oh, why are we not interacting? Do entities, we both have a rigid body, right? Okay, rigid body. All right. What we must have is, let's make these settings like I've got here just in case. So you are scale 10 by 10, okay. And closing collider is 0.09, which I've got 0.85, good enough. We want this one to not be triggered. The other one is 0.9, even bigger. This is a trigger, and there we go. Okay, so I thought this would have them bounce off each other at this point. Maybe not. All right, well, must be missing some kind of a collider here. Oh, you know what? I haven't implemented that yet. That's why. All right, I'm just talking to myself. So what we're going to do with this enemy script is we're going to have a very simple AI. So we're going to look to see if we have a target. How do we see if we have a target? The onTrigger enter function gets activated, which means that something collided with that Collider2D. I'm missing the collider on the player, that's why. If we have one, we're going to follow. If we do not have a target, do nothing. If a target comes into view, we would make basically we're going to do the 1.1 and 1.2 here. If a target comes into view, we would also have it say that there's a target. So we could pop up text saying, I found you, or something like that. So what we're going to do is we're going to handle a couple of new attributes here. So we have hide in inspector. Basically, we can make public objects that are not visible to Unity, but we can still make them public so that other entities can access them programmatically. So I think I'm just kind of zipping back and forth here between slides. Sorry, what I missed was I definitely missed a slide in skipping through because sorry, we need bullets, key. Okay, yeah, I missed this last one here. Add a circle collider to the player as well. Sorry, this was irking me that the player wasn't bouncing off of the sun-ish here. So circle collider for this guy, 0.09. No trigger. So our player has a boundary, and what we should see. There we go. Okay, that's better. So I'm moving, basically these guys are bouncing into each other. Okay, I feel better now. What I was trying to get across to you earlier was that if I make the bigger collider a trigger, what we're going to see is, sorry, if I turn it off from being a trigger, getting my checkboxes confused here. There we go. All right, so you basically have like a repulsion shield here where my giant collider I'm actually bouncing off of. So if you made that an actual physical object, you could do kind of a lightweight run away from me kind of thing where you're never allowed to get through that. All right, so we're good now. Follow the slides. That's what I should have been doing. All right, so we're going to create a enemy controller script here now. So scripts, create C# enemy controller. All right. And we're going to add some attributes here. So a speed, do we have a target? What is the target? And then a reference to our private rigid body. All right, so I'm going to access these guys. So again, this hide in inspector will hide this public bool here. So if I save it, and I link up the script here, I look at my enemy object. Here's my enemy controller script down here at the bottom. If I go ahead and comment out this hide in inspector, you'll see has target pop up. So there's has target, yes or no. You could use that for debugging if you wanted to, but basically we don't want the designers to have access to this. Alrighty, so moving right along here. We're going to use the awake function to basically get a hold of our object. So again, if you don't want to, basically if you want something to happen right away, when this object is instantiated, awake will happen before start will. What's going on here? There we go. All right, so we have awake, and then our update function, I'll explain after I copy and paste it in here. So if we have a target, we're going to get the distance to it. All right. Formatting. So basically, every frame, if we have a target, we're going to try to transform ourselves closer and closer and closer. All right. And then we have some extra functions in here as well. Obviously, this is going to do nothing because has target is false. And I'm just kind of glossing over these other ones. Basically, we're handling a distance calculation automatically using the vec3. All right. If we're farther away, let's follow them. But what we're going to be adding in here are three functions. So we're going to add an onTrigger enter 2D, an onTrigger exit 2D, and a follow function. So onTrigger enter will get called whenever we enter that larger collision radius. Again, this function becomes active when we set a collider and click is trigger. If it's not a trigger, this doesn't execute. So it's going to pull in the object that we collided with, and we're going to see, is the object a player object? If so, we have a target. The target is this object. If we are done colliding, which means that the player has left the sensing radius, we're going to basically invert our objects here. So we don't have a target. The game object is null. All right. And then our follow function is basically the exact same thing as our movement function. We're going to add a force to the enemy here. All right, so again, this is basically just linking everything we've done so far together. I'm not going to worry about formatting this in the interest of time. This is an interesting function call right here, though, if you ever need. So collision.name.equals player object. If I had called my player something else, basically what is the name of your thing that you're interacting with in the hierarchy, right? So here you see its player object. Its name is right there. So basically, collision, which is a collider2d.name, has the property of that object, right? It's the parent's name is its name, basically. All right, so player object. I haven't changed any other variables, I think. Okay, so this should compile. And now what we have is, I'm just making sure I put everything in that we need. We have somebody that's following me. Right? I'm not doing anything right now. I am inside of its sensing radius. And you see this kind of orbiting characteristic again because we're applying physics forces to it in terms of like a ball roller type of thing. I can still bounce into it and push it away, right? Because I have a rigid body and a collider. So now that I pushed him all the way this way, I guess this way since my camera's inverted, he's not going to come back and try to find me because I'm outside of its sensing radius. Okay, if I go back inside of it, which I'm going to assume it's over here, I don't have like a mini map or anything set up. You can see we're outside of the bounds of the world. Obviously, you'd want to bound this a little bit more intelligently. But we have a follower. Very, very simple AI. I'm curious if this reference tracks for anybody in here. There, you have this guy following you around. Which I'm completely spacing on the name now. Oh, crap. What is this thing called? Hmm. This is a Super Nintendo game. I had to remember it yesterday to find it. Crap. Sinistar, that's right. Sinistar GIF. It was a classic one where basically you had this horrible head coming after you. You know what? You need the full effect here. Sinistar. Oh, come on.
I am Sinistar. Beware, I live. Run, run, run. Beware, coward. Run, coward.
Yes, Super Nintendo was a different time. So I'm basically going to leave the rest of this to you guys, if you want to follow through with it. So how would we finish this up? We would add scoring, we would add text, we would add a menu, preferences. Obviously, I skipped over the bullets. Let me close this out and open up the other one, just to kind of show you where we were at with the other one. Because I basically went through the whole thing in a different project. So I'm going to close this one out. Yeah, bullets. You would have a game manager for basically what are the spawn points. Are we going to create different types of enemies? Are we going to have like a high scoring type of thing? There's a lot of things that you could do. Again, this is all of the extra bits. So you get the really cool game, cool. I mean, again, consider this in terms of simulation or whatever you're doing. You get the basics down of your actual um, movement, your interaction, your gameplay, however you want to handle it. And then you have to add on all the extra stuff, which takes you twice as long to do this. So here is the game with bullets. So basically it is, it's orange, not red. My player is white, not teal. I'm using the arrow keys to move around, and I'm going to fire in the direction of my mouse. So I kind of get this spray. But you can kind of see I'm just holding the mouse button down. I I intentionally didn't follow the tutorial for this one because I left the colliders and the physics on in the bullets because I thought it was a little bit more fun to have it interact with myself. Obviously, you would turn off collisions or like turn off having it hurt you or something like that. But I can just kind of do a like a Super Mario Sunshine with a little Hydro Blaster. I can kind of move this guy around with that. Or he's going to try to follow me if he's not having forces acted upon him. It's a little bit more muted with the settings that I've applied. But there, physics-based 2D space shmup kind of a thing going on here. What you can also see here on the left, so there are all these bullet object clones. These are all the instantiated bullets that are being created. So if actually let's follow these bullets here. So just kind of watching them as they go, you see them over here on the left, and then they're gone. So basically they're instantiated when I click the mouse button, and then they're destroyed once their lifetime ends. So let's actually pull this open here just to show you. Yeah, so lifetime is 10. Basically, once the lifetime goes away, once it hits 0, destroy that object. And again, you can do this kind of a, this basically this type of a setup where you instantiate and destroy. So if I click player controller and I'm going to instantiate basically a new bullet every time I hold the mouse button down. You could do it that way. Again, you might hit a performance threshold where things slow down just because you have so many objects. Instantiating and destroying has a little bit of an extra overhead rather than creating a pool of them and just kind of having them ready to go. But again, use what's going to work for you. If it's a very simple game, you're probably not even going to worry about it. If you get something complicated, you get like a, oh, what's a good complicated, what's the red and black colored shmup? Oh, crap. It's, color is the wrong word. Ikaruga. There we go. Thank you, Google. So you get something kind of crazy with a lot of things happening. There we go. There's a nice image there. Like so many effects happening on the screen that you probably would want to instantiate a pool of things beforehand. But yeah, anyway, so that is 2D Unity. Everything that you've learned so far, if you are trying to transition from 3D to 2D, you don't want to handle models, you want to deal with sprites. 2D is going to be a lot easier for, the basics because you're only dealing with 2 dimensions. Pretty much everything that we learned in 3D is going to have a 2D analog, right? So like sprites is going to be your model. Colliders will be collider 2D, rigid bodies, rigid body 2D. So Unity makes life very, very easy in terms of, having these interactions, having all this kind of a setup. And again, the rest of the slides, if you wanted to go through it, basically you're creating a weapons factory. Basically, you're creating oh, this is actually something I should mention to you before we go. This is helpful if you're creating the game engine for a designer. You can tag something as create asset menu. And what this does is that in here, in my assets, I can do create weapon, right? So this is something that I scripted, and then you have the basic settings for what your weapon's going to look like, right? What is the bullet? What's the name of it? How many bullets can it hold, right? So basically, I just have a little bit of a code blob here for this public object, and then I can derive any number of objects later on in Unity. I don't have to program them all. So something which I really wanted to touch on before we left, basically. So you don't have to like have a script for every single weapon type, like if it's a shotgun blast or a laser or something like that. You just create a single entity and derive from that. Other than that, yeah, we went right up to the time. So anybody have any questions at all? And I forgot to hit record again, so we're going to have to pull it down directly from Twitch one more time. So other than that, pleasure having you all once again. Again, Thursday, Olivia and Connor, please send me your presentations so that we can get those up there. And then our last lecture from me will actually be next week. So we will talk then about ragdolls a bit. And that's going to go back to 3D land. Anyway, I hope you all have a wonderful day, and I will talk to you on Thursday. Bye-bye.